Shortly before 10 a.m., a plume of hot water, mud and rock erupted from Black Diamond Pool in Yellowstone National Park's Biscuit Basin, just about 2 miles northwest of Old Faithful. No early warning was detected by monitoring instruments. The blast damaged nearby pavement, and the basin remained closed as geologists assessed the activity. Fortunately, no one was hurt. Geologists examining the deposits have noted that the rocks ejected by the blast were glacial material, sandstone and siltstone, and gravel that lie just beneath the silica sinter that forms a layer on the surface. No rhyolite bedrock, which lies about 175 feet below the surface, was found. This suggests that the blast occurred at a much shallower depth and did not disturb the bedrock. The eruption was directed mostly northeast toward the Firehole River, and large boulders, some several feet across and weighing hundreds of pounds, fell in that direction. This coincidental direction may be why no one was standing on the boardwalk at the time. Hydrothermal eruptions occur when liquid water boils and turns to steam in the shallow subsurface. This kind of transition happens all the time in established geyser systems, like Old Faithful or Steamboat Geyser, where a clear channel system allows steam and hot liquid water to take an unobstructed path to the surface, producing a geyser eruption. However, when the liquid vapor mixture is in a confined space without a clear channel system, the pressure from the expanding steam bubbles eventually overcomes the strength of the rocks, and an explosion occurs. In the case of Black Diamond Pool, the change occurred in a shallow subsurface reservoir of hot water. Silica precipitation can clog the channels or pipes in the reservoir, causing steam and pressure to build up. Data collected by geologists from the debris from the explosion will provide more details about the actual conditions at the time of the incident. Hydrothermal vents are more common than you might think in Yellowstone National Park. These vents are the most frequent but least damaging hazard, compared to strong earthquakes, lava flows and domes, and caldera-forming eruptions. On average, there are several hydrothermal vents of varying sizes somewhere in Yellowstone National Park each year, often in remote areas that might go unnoticed. Some of the largest hydrothermal vents in the past 150 years in Yellowstone National Park occurred in the 1880s at Excelsior Geyser, which is adjacent to Grand Prismatic Spring in the Midway Geyser Basin. The Porkchop Geyser vent in the Norris Geyser Basin is perhaps the most famous in the area. This event was witnessed by several visitors but resulted in no injuries. The event was detected by a nearby monitoring instrument designed specifically for this purpose. Without data from this instrument, the unobserved event might never have been recognized. The Yellowstone Volcano Observatory specifically targets expanded hydrothermal monitoring as a goal to address the threat posed by these small but dangerous hydrothermal eruptions. The monitoring equipment installed at Norris Geyser Basin is a first step toward that goal. Much smaller events are even more common, such as the rare eruptions at Ear Spring, near Old Faithful Geyser. But larger events can happen, too. Since the end of the last ice age in the Yellowstone area about 14,000 years ago, there have been more than a dozen hydrothermal explosions that have left craters hundreds of feet wide. The largest such crater is, of course, the largest known hydrothermal explosion crater on Earth. It measures about 1.5 miles across and was formed in an event about 13,000 years ago in Mary Bay, along the northern edge of Yellowstone Lake.